Hello, Mr. Lee here. All right, this practice is going to be on describing correlation. You'll have a lot of vocabulary practice here. Um, the main words you're going to see are if the correlation is strong or weak, if it's positive or negative. Sometimes there's no correlation, and sometimes it's a perfect correlation. Okay, so relating everything to straight lines. So here's the first example. Describe the correlation. It looks like you can draw a straight line through most of these points. So we call it the average of these points. Okay. Um, so it is positive because going from left to right, it's going up, kind of like a positive slope. Okay, looks like a line would fit through a good average of these points. And then the points are pretty much close together. So I would say this is strong and positive. Okay. Describe this correlation. Okay, so if you were to draw a line of best fit, it'd be kind of tough because you see a lot of points that are down here, but then you have some that are way up here. So you could still draw a line of best fit, okay? But it would be probably weak, okay? You could curl some type of relationship with these points, okay? But if we're just talking about a line, and we're just talking about your line of best fit, it's not going to really have the points super close to the line, right? So the line I'm kind of picturing is maybe somewhere here, okay? But there's going to be still a lot of points that are far from it, okay? So it is negative in nature because as we're going towards the right, as x is increasing, your y values are decreasing or going down, okay? So our options, we don't even have to distinguish between strong or weak, but I would say this is probably weak, okay? Okay, describe the correlation. This is an example of no correlation. Okay, so the points are just kind of all over the place. You could try to draw a line here, maybe a line here, maybe a line here, but there's no real good average of all the points. So we'll say this is no correlation. Okay, so this one looks like a negative correlation. You can probably get a line somewhere around here. Okay, our options don't ask for weak or strong. This one's probably between a weak and strong. It just kind of depends on the rest of your data. But we just have to distinguish that it's negative. Okay, going down from left to right. Let's do a couple more here. Describe the correlation. So first of all, I don't think there's many examples on this GIM kit where there's a perfect correlation, but the only types of correlation that's perfect is if you see a perfectly straight line, if every single point can actually fit on the line, okay? So this one we do have a distinguishing between strong and weak. So let's see. From left to right, you can maybe draw a line like this, okay? Looks like this correlation fits better with a curve, okay? But if you were drawing a straight line with your line of best fit, it should probably be a weak and positive, okay? It's going up from left to right, but then you have a lot of points that are slowly increasing all the way towards the end here, and then they kind of bump up. So we'll say it's weak and positive. Okay, so I'm gonna move over to this exercise. This is also in your Canvas page. So this is just helping you to describe a little bit more in detail of the trend. Okay, you're still talking about the correlation, right? You can take a graph and see where the line of best fit can appear, but then we're going to focus more on how to describe it with these actual variables. Okay, so for example, it asks which statement is the best description of the association between these variables, right? So you have an association between group size and time in minutes. Okay, so let's read through each of these options and see which one actually fits the best. Option A says larger groups tended to take more time to solve the puzzle. Okay, so if the group size is big, we're going towards the right on your x-axis, right? So bigger group sizes closer to here. It says, again, in option A, those larger groups tended to take more time to solve the puzzle. So if that was true, I would be seeing your time at a bigger amount with your bigger group size. So that would be like a positive correlation, which is definitely not the case here. Okay, So option A is not good. Option B says larger groups tend to take less time to solve the puzzle. That's what we want. Okay, so towards the beginning, group sizes are smaller. It takes a lot more time, and then as group sizes increase, it takes less time. Okay, so that is your correlation. Okay, we'll do total of 4 here. So again, it's the same question: which statement is the best description of the association between these variables? Okay, so it looks like we have age on the x-axis and then internet use on the y-axis. So it looks like this is all over the place, right? This is going up and then going down. There's no pattern really. There's no consistent correlation, consistent pattern. So we'll find the option that has no correlation. Option A is increasing and increasing. That would be a positive correlation. Option B, internet use was highest for those between 20 and 35 years old. So that is true. But then there's no option that says no correlation. I was kind of assuming that, but this second option is true. If you're looking at all the data between your 20-year-olds and 35-year-olds, we have the highest internet use. So we'll go ahead and pick that. Okay, next one. So same question, which statement is the best description of the association between these variables? Okay, so we have average income on the x-axis, and then life expectancy on the y-axis. So it looks like there's a positive trend here, positive correlation. Generally speaking, as the x values increase, the y values are also increasing. X values increase, y values increase. Okay, so let's see which statement says that. Countries with higher income tend to have longer life expectancies. Right, so higher income, higher life expectancy, or longer life expectancy, right? As X increases in income, your Y increases in life expectancy. So option A is good. All right, one more here. Looks like we have a negative correlation, right? As your heart rate is increasing, your life expectancy will decrease, goes down, right? Starts high with a low heart rate, and then higher heart rates will have a lower life expectancy. So let's see which statement communicates that. Option A, species with higher heart rates tended to have longer life expectancies. So that would be false, because then we would see a lot of points over here, right? Higher heart rate, higher life expectancy. Option B, species with higher heart rate tended to have shorter life expectancies. That's what we want. Okay, so in these problems, try to connect the concept of your positive, negative correlations with how these different data values are increasing or decreasing.